Okay, yeah. Good evening, everyone. So welcome back to our session. Let's wait for a few minutes so that remaining people will join so we can start it. The project is done. So in today's session, we are going to start the Kubernetes. So let's start this one. Okay, so let's start the Kubernetes session here. So previously we know Docker Swarm, right? So what is the Docker Swarm basically? It's a container orchestration tool. So like Kubernetes is also nothing but a container orchestration tool, but Kubernetes is far more advanced than Docker. Why it is far more advanced means, first of all, let's see what Docker Swarm cannot able to do. Wait. What Docker Swarm cannot do. First of all, Docker Swarm cannot do auto scaling. Second thing, Docker Swarm cannot do load balancing. Third one, Docker Swarm can't have default dashboard. And fourth one, so Docker Swarm mainly is it for easy application, not for complex applications. See now here, first of all, here we don't have auto scaling and we don't have any load balancing and we don't have any default dashboard. Of course, we can use Portainer, but that is not a default dashboard. So, but Kubernetes is having the default dashboard. Finally, use it for the easy applications. So, but whereas if we talk about Kubernetes, first of all, it's an open source container orchestration platform. Just like Docker Swarm, Kubernetes is a open source container orchestration platform. It is used to automate many manual processes like deployment, we can automate, sir. Managing the containers, scaling the containers, load balancing the containers, everything we can automate. Whatever Docker Swarm cannot automate, Kubernetes will automate for us. And Kubernetes was initially launched by the Google, who developed the Kubernetes, but the initial name was Borg actually. It's not the Kubernetes. Initially, they developed an internal system to manage some thousands of Google applications. Tell me any few Google applications you know. Any few Google applications. Google Drive, Google Photos, Google Classroom, Google Mail, everything we have, right? Google Browser we have, everything. I mean like Chrome, Google all there. Then, so we will be having some n number of applications for the Google. So what these guys done, these guys found it is very difficult to manage this many applications. So they created a internal system called Borg, BORG. What is the name of it? Borg. Okay. So few members of Google created a big cluster which is used to manage multiple apps on the Google. That is what we can call as Borg. But later, Google donated the Borg to CNCF actually in the year 2014. CNCF means it's a cloud native computing foundation. It's a cloud native computing foundation which is going to develop the softwares and applications for free of cost for our use. Okay. So these Google donated the Borg to CNCF in the year 2014. After that, CNCNF maintained that Borg and they renamed it to the Kubernetes and they released into the first version of 2015. In which year it came into the market? 2015. Initially, it was created in 2014 only, but Google given that Borg to CNCF. So CNCF released the Kubernetes in which year? 2015. First of all, why initially Borg was created? Hmm? To manage the Google applications. So, but they want to make it free and open source. That is the reason they're given to the CNCF. And Borg was renamed as now Kubernetes. Correct or not, sir? That's it. Now, if you see the architecture of this one, Kubernetes, if you see here, the word Kubernetes is basically derived from the Greek word actually. So the spelling is Kubernetes and shortcut is what we can KDS. Why? Because if you see first letter and last letter is K and S. In middle, are you seeing 8 letters? 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is the shortcut of Kubernetes. Basically, we need to call it as Kubernetes, but the shortcut is also called as KDS. Basically, this Kubernetes is the word that comes from the Greek language. Which language? So in Greek, the exact meaning of Kubernetes is called as halesman. Which one? Halesman means the person who drive the ship. Is it a ship steering or not, sir? All of you watch movies of Jack Sparrow. Hmm. So in that movie, like Jack Sparrow used to rotate that wheel, right? Why they used to rotate? For direction and to increase and to control the ship. Here also I have the Docker. Basically, if you observe Docker, Docker is like a ship which is having containers, right? Docker is a ship which is having containers. To control the ship which is carrying containers, we need to have the steering. That steering is here Kubernetes. Same like we will be having some thousands of containers in real time. To manage all of those containers, we need to have that steering. That is Kubernetes here. Of course, Docker Swarm will do it. But we have seen limitation of Docker Swarm or not, sir? What is the limitation? No auto scaling, no load balancing, no default dashboard, and use it for only small applications, not very big applications. But Kubernetes is not for like that. It can do auto scale, it can do load balancing, it can maintain the complex applications like ChatGPT. You know ChatGPT? ChatGPT is hosted on the Kubernetes cluster, which is having 5,000 nodes in a cluster. How many nodes? 5,000 nodes. Like that. And almost all 150,000 containers. How many? So that is the capacity of this Kubernetes. Okay. So already we have seen what are the limitations of Docker Swarm and Kubernetes. Now coming to this one, already this intro is done. So if you see the architecture now, sir, are you able to see the architecture there? I'll give you a couple of minutes. Try to understand that architecture and tell me what you understand by this seeing that. Online YouTube, just see the architecture for a couple of minutes and tell me like what you understand by it. Are you able to understand anything there? No? Yes. Tell me what is it. Just tell me what you understand. Okay. That's it. Okay. So by seeing there, you understand there is one master and two worker nodes. Hmm. Then next, what about you? No, you are two are both discussing. That means you got it. No. Okay. Forgot about this Kubernetes architecture. You know Docker architecture, Docker Swarm architecture. First of all, in Docker Swarm, what do we have? We have the cluster actually. We have the inside cluster. You have the nodes, master node and worker node. Inside node, what you have the containers. Inside container, what you have? Inside container, what you have? First of all, inside cluster, you are having the nodes, and inside nodes you are having the container. Inside container you are having the application. Same architecture for Kubernetes also, but the only difference is here between node and container you will get the pod actually. What you will get? Pod. I'll show it here. Wait. First of all, it's a big cluster. Are you seeing this cluster? Inside this cluster, are you seeing nodes, master nodes and worker nodes? Inside nodes, are you seeing the pods? Okay. In this pod, you will be having container. What you have? Inside container, what you have? Application. That application is used by the users actually. That is how this is going to work. Let me make you more explain here. Wait. So if you go and see, you can see this architecture. Wait. Oh, that is not here. Fine. You can see. I have given the clear architecture. First of all, in Docker, you will be having cluster. C for cluster, N for node. Again, C for A for application. But in Kubernetes, first of all, you will have cluster. Inside cluster, you will be having node. But between node and container, what you will be having here? Pod, right? So after pod, you will be having container. Inside container, you have the, if you understand this one, the Kubernetes is going to be very, very easy. Okay, sir, fine. But how to make it understand very, very easily? I'll teach you one small technique. If you remember this technique, you will never ever forget the Kubernetes. All of you watch Telugu movies? Hmm? How many of you don't watch? Just I'm asking, man. You don't watch. Okay, then. No, you're from Maharashtra. Okay, fine. If you watch Telugu movies, this Kubernetes cluster is going to be very, very easy, sir. Hmm? First of all, you know Megastar Chiranjeevi? If you know Chiranjeevi, cluster is very easy. Hey, trust me. You know Chiranjeevi? Then cluster is very easy. First of all, in Mega family, who is the first hero? Chiranjeevi. After Nagababu we have. And after that, Pawan Kalyan. After that, Ram Charan. After that, finally, Allu Arjun is the biggest hero. Now see here, C for cluster, sir. C for what? Again, N for node. Nagababu, not node. P for pod. C for again, container. And A for application. Done or not, sir? First of all, what I said here, C for not cluster. C for cluster. Like if you see the family structure of Megastar, Chiranjeevi, Nagababu, Pawan Kalyan, and like Charan, Allu Arjun. Here also cluster, node, pod, container, application. Is it clear now? If you remember this formula, Kubernetes is going to be very, very easy. Otherwise, you cannot able to understand, sir. That is the reason why to watch Telugu movies. At least for understanding Kubernetes. Is the architecture clear now? Everyone. Online, what about you? Is the architecture clear? Can you please confirm? Okay, fine. Yes, Nikhil, in Docker we have containers. In Kubernetes we have pods. Inside that pod we have the containers. Fine. Fine. So now let's understand the components of this cluster. First of all, when it comes to the components of Kubernetes, we will be having total 7 components. 4 on master node and 4 on worker node. How many components we are having? 7. In master node, you will be having 4 components. In worker node? In master node, the first component is going to be API server. Which one? API server is to communicate with the user, sir. For example, if user want to give a command and take the response, we need to communicate with API. If you see this diagram, you'll get the clarity. See, for example, this user is asking to API server, I want to see the pods. Okay. API server will take the input from the user, execute it, and it is going to give to the user. Okay. So simply for communication with Kubernetes cluster, which component is responsible? API. It will take the command, it will execute and gives you the output. Second one is going to be etcd. We can call as etcd also. What is second component? Simply it is nothing but database of your cluster. It is nothing but database of your. That means this etcd will store the complete information of your cluster, sir. For example, if your cluster is having 100 pods and 200 containers, the complete information of the pods, containers, and each and every information of the cluster is going to store on the etcd. Okay, so etcd is nothing but database of your cluster. It stores complete information of a cluster. What is third one? Scheduler. Scheduler main purpose is to select the worker node to schedule the pods. For example, let's consider, see, scheduler is going to work like this. By default, I have one node. It is master node, worker node 1, worker node 2. When I want to create a pod, in master node, I have the component called scheduler. Which component? This scheduler main purpose is to check these two worker nodes and find the perfect worker node to place this pod. Okay, to place that pod. But how scheduler is going to find the best worker node? That's the question. So how many servers do I have there? Two worker nodes. How many worker nodes? And one more thing, in Kubernetes, master node will not place the pods. It's not possible. Okay. In Docker, some master node will get the pods, sir, but here master node will not get the pods. Only worker nodes will get the pods. For example, this worker node is having 1 CPU and 1 GB of RAM. 1 CPU and 1 GB of RAM. And second worker node is having 2 CPUs and 2 GB of RAM. How many CPUs? And how much of RAM? 2 GB of RAM. Now, which one is better? Second. Why? Because second one is having more CPU and more RAM. So, scheduler will check each and every worker node and it will give the scoring actually. Which worker node is having the best hardware properties and hardware resource. Now, scheduler will mark it as best node and automatically it is going to place the pod on the best worker node only. I mean, it will only select, but API server will schedule the work. API server is going to schedule the pod actual. Is it clear now? So first of all, API server main purpose is to communicate with user. Take the command, execute, and gives you the output. Second one, etcd. It's a database of the. It stored complete information of a cluster. Third one, scheduler. What is the purpose of scheduler? Select the worker node to schedule the pods. And how it is going to select the best one depends upon the hardware properties of a. And fourth one is controller. Controller main purpose is to control the Kubernetes objects. It is going to control the Kubernetes object. Like for example, service we have, node we have, network. So these are the Kubernetes objects actually. This is going to control by the controllers. In real time, we have a lot of controllers. So mostly we use control to control the Kubernetes objects. Okay, fine. Next one is going to be worker node components. But before going for worker node components, is master node components clear for all of you guys? Everyone? Fine. In worker node, first of all, we will be having a component called kubelet. What you are going to have? The main purpose of kubelet means basically it's an agent. Kubelet is it will inform all the activities to the master. That means, for example, in worker node, if I create a pod, in worker node, if a pod is created, it will tell to master node that like master node, in the worker node one, a pod got created. If I stop this pod, it is going to tell to the again master node. So the pod has stopped on the worker node. And if I delete this pod, or if I change anything on the worker node, each and every information will be carried out to the master. So it's an agent which will inform everything to the. And one of the most important thing about the kubelet is, it is the reason to create containers on the worker node. What is the main reason to create the containers on worker node? Kubelet will take the image from Docker. It will create a container inside the pod. Is the point clear, sir? Next. Kubeproxy. Kubeproxy main purpose is to deal with the networking. Already you know. In this big cluster, we need to communicate with each and every worker node. So the worker node and master node communication is going to define with the help of kubeproxy. Deal with complete networking like IP address, networks, ports. Every networking is going to manage by the kubeproxy. And final one, pod. Pod is nothing but group of containers. What is a pod here? In Docker, you will be you will be working with the pods. Sorry, you will be working with the containers in Docker. But in Kubernetes, you won't work with containers. You are only working with the pods itself. With whom you are working? Why? Because Kubernetes don't know what is container. Kubernetes knows only pod. This pod will manage the containers. Point clear, sir? Inside that pod, we will be having container. Inside that container, we will be having the application. So all of these components together, we can call it as cluster of the Kubernetes. Again, one more time, let's discuss. Okay. So first of all, tell me the architecture of Kubernetes. First of all, we have the inside cluster, inside node, pod, inside pod, container, inside container, application. In components of master, what is the first component? Main work is to communicate the user. And etcd means DB of cluster. Third one, scheduler means select the worker node to schedule the. Fourth one, controller. Control the Kubernetes objects. And here, worker. In the worker, first one is kubelet is a. What is the work of kubelet? Inform everything to the. And second work is. No. What is the other work of kubelet? It is responsible to create the containers. It will take the image from Docker Hub. It will create the container and it running the pod actually. Second one, kubeproxy. Main purpose, networking. Third one, pod. What is the meaning of a pod? Group of containers. Inside pod, we have the application. Is it clear, sir? No? So all of these are the components of a cluster. All of these components of a. And what is the main point here? The main point of this cluster is all components of cluster will be created as a pod. Remember, each and every component of the cluster is going to create like a pod. For example, scheduler. Scheduler is going to create like a pod. etcd, it will create like a pod. Kubelet, it will create like a. That means complete Kubernetes architecture. Each and every component is going to treat like a pod itself. What is the meaning of pod? Group of containers and controller. So like controller, Sunil, if you want to learn about controller, you need to wait for some other concepts, Sunil. Okay, then you'll get the clarity. Fine, sir. Now, if you want to create any application, if you want to create anything, first of all, you need to create the cluster. What you need to create? First of all, what is the meaning of cluster? Already you know. Group of servers. In Docker Swarm, we created the cluster. In Ansible, we create the cluster. Now in Kubernetes also, you are going to create the. When it comes to the cluster type, basically we have two type of clusters. How many? First one is self-managed. Second one, cloud-based. Self-managed means we need to create them and we need to manage them. Cloud-based means cloud provider is going to manage them. Basically, we create on the cloud and that is going to manage by the cloud itself. So my question is here, in real time, which we are going to use, self or cloud-based? No, we use both. Depends upon your requirement. Okay. For production level works, cloud is better option. Of course, I'm not telling self-managed is not a good option. A lot of people majorly prefer this one, cloud-based. But for local, Minikube is best. Okay, let's understand like how it is going to work for you. In self-managed, we need to create them and we need to manage them. First of all is Minikube cluster. Which cluster? Minikube is nothing but a single node cluster. That means here you will be having only one server. What is the meaning of cluster? Master node and worker nodes. But here it is the manager node, it is the worker node. Second one is going to be KubeADM. Which one? KubeADM is nothing but a multi-node cluster. That means you will be having multiple nodes, master node and worker nodes. But it is a manual way of creating the cluster. Same like in Docker Swarm, we create the servers, we install them, we copied the token, we join them, right? Same process. But in real time, we worked on, like I worked on KOps, which is very, very high-end tool in entire Kubernetes concept, okay? For cluster management. It's a multi-node cluster which is going to automate the entire infrastructure actually. So if you want me to know, how many of you know AWS here? None of you know? None of you taken training of AWS? Done? Okay. So a question for you basically. If I want to create one end-to-end VPC, one end-to-end auto scaling group, one end-to-end elastic load balancer, as well as like subnets, everything, how much time it will take? Hmm? Like how much rough estimation time? 1 hour, right? But in this tool, we can create within 5 minutes. That too, if you run a single command. How many commands? One command can create the entire infrastructure of our application. That is the KOps tool, which is very, very high end. So I'll teach you. Okay. So how many things we have in self-managed? Three. First of all, Minikube. Minikube is a single node cluster. Second one, Kubedium. Kubedium is a multi-node cluster. Third one, KOps. KOps is multi-node cluster, but we are going to use it as automation way. Second one is going to be cloud-based, sir. In cloud-based, we will have different clouds. In AWS, you can use EKS, Elastic Kubernetes Service. Azure, you can use AKS, Azure Kubernetes Service. Like in GCP, that means Google Cloud. You can use GKS, Google Kubernetes Service. If you open your AWS account, I'll show you. Wait. You have something called EKS, Elastic Kubernetes Service. Of course, for Docker Swarm also, we have one cloud-based service. We have something called as ECS, Elastic Container Service. That is the alternative of basically Docker Swarm. Okay. But a lot of the times we don't use cloud-based clusters, or we can use our self-managed. So if you go to here, click on the search box here. In the search box, just type like this. Are you seeing EKS, Elastic Kubernetes Service? If you go and see here, you can see the EKS cluster. You can create the new one. Okay. That is cloud based. That means your cloud is providing the cluster. But here we are going for self-managed. So in that self-managed, what is the first one here we are going to learn? Minikube. So basically, Minikube is a tool used to set up the single node cluster in Kubernetes. How many nodes we can set up? It contains the API server, etcd, and container runtime. So in real time, we use for developing and testing environment. Which environment? And for experimental purpose. In local means on our local laptops. But for production, we don't use this one. Why? Because it will have only one node. You know, what is the disadvantage of using one node? What will happen if I use only one node, sir? Correct only you are telling, yeah. Tell it loudly. If I happen one node, if there is no backup, right? If I use everything on one node, if the node got deleted, we don't have any other nodes to give the backup of application. For that purpose, maintaining one node is not recommended in real time. That is the reason we use high availability. What is the meaning of high availability? But Minikube is going to be a single node, right? Okay, we use for developing and testing. Here, master and worker runs on the same machine server. That means in this single server only, master node components will be there. Worker node components also will be there. It is platform independent, run on any kind of operating system. Installing Minikube is simple when compared to other tools. If you install Kubedium or KOps, it will take a lot of time. But Minikube will be installed within 2 minutes. How many minutes? Note, we don't implement this on real time for production. Okay. This will be implemented for developing and testing. But for production, are we going to use it? No. Is the concept clear now? Again, Minikube is a tool used for single node cluster. Here, we use the API server, etcd, and everything. We use for developing and testing activities mostly. Master and worker nodes components will be running on same machine. It's platform independent and it is very easy to install. And what is the note point here? We don't implement this on real-time production. So if you see the requirements, how many requirements we have? First of all, two CPUs is required, sir, for Minikube, and 2 GB of. Generally, what kind of instance we will prefer? Instance type T2 micro. T2 micro will be having one CPU and one RAM, but T2 medium will be having two CPUs and almost 4 GB of RAM. So this is suitable for us. How much of disk space we want? EBS volume unit is 20, and internet connection and a container tool like Docker. Okay, these are the requirement actually. Without these requirements, we cannot create the Minikube cluster. Again, see one more time, how many CPUs you want, how much of memory, and how much of disk space, and internet connection, and one Docker tool. Okay, so now let's create this Minikube server first of all. Select Ubuntu. Okay, what you are going to select here, and select the version 20. Don't go for 22. Why? Because we always used to maintain n-1. You already know this point, right? Of T2 micro, what I'm going to use here? T2. But because T2 micro having how many CPUs? How much of RAM? But T2 medium has 2 CPUs and 4 GB of RAM. Satisfying our requirement or not, sir? Take all traffic, and how much of EBS required? That's it. Now your Minikube is created, and here we are going to run the Minikube script. Already you know. GitHub, Raham Sheikh, go for all setups. So here are you seeing the Minikube Ubuntu Docker Minikube.sh? This one. So this script you need to run actually. So in your notes, I already given the script here. Same script you can see. See this one. So let's connect to your EC2. Run the script now. sh minikube.sh. Now automatically this script will set up Minikube in 2 minutes. Wait for a couple of minutes, okay? You can see it here, Sunil. It's a script actually, which will download Minikube and install everything. I'll explain it. First of all, edit setup now. I'll explain. It's not still done yet, so I'm waiting for it to finish. I'll explain the script. Now, if you see here, your Minikube is running. So now see what is the script here actually. First of all, if you want to set up the Minikube, you need to understand like what is running inside. I'll explain the script in a couple of minutes. Just see how it is working exactly. See here. First of all, in the first two commands, you are updating the server. apt update -y to get the list of packages to update, and upgrade is going to update them. Okay. In second command, I'm going to install Docker. Basically, how we install Docker, yum install docker.io. But in Ubuntu, I'm going to download the Docker from the script actually. Are you seeing the script? Its script is predefined. In this script, you have complete end-to-end Docker setup. But to download this script, I need to use curl command. Which command? Curl command is like check URL, which is the alternative for duplicate command. What is the purpose of duplicate command? Download files from? Here also from the curl command, I am downloading this script from internet. Hyphen o means output. Output is in which format? Get docker dot. Now I'm running this script, right? But to use curl command, I need to download the curl command from the Ubuntu. By default, in Ubuntu, we don't have curl command. We need to download that one. And the difference between duplicate and curl command means duplicate is having some limited protocols, but curl will support for all kind of protocols. Okay, that is the main difference. So step number one, updating the server. Step number two, installing the. First of all, install curl command. From the curl command, you are downloading the Docker script, and Docker script you are running to install the Docker. Third one is installing Minikube. Already we said Minikube is a single node cluster. We need to create it for the running the cluster. But sir, here what happened, you know? This Minikube is not a default Linux command. That means if I want to use Minikube command, I want to download this command. What I want to do? So whenever if some commands are not available in Linux, we are going to download on binary format. Are you seeing I'm downloading from a binary file? This is. After downloading this file, I am moving this file to user local bin. And after that, I am giving the executable permission. What I'm doing? And I'm checking the Minikube is working or not. Now here the main point is here I have written very clearly. When you download a command as a binary file, it need to be on user local bin. I already said Minikube is not a default Linux command. If I want to use that command, I need to download it. But whenever you download, you need to move it to user local. Why we need to move to user local bin means all the commands in Linux will be on user local bin only. For example, touch command, mkdir, cp, mv, all these commands we are seeing, right? Every command that you are executing in Linux is going to be on user local bin only. If you don't place the file there, that file will not work as a command. That is the path for all the commands. And after that, we need to give the executable permission for that binary file. We need to give executable. Why? Because you download on file format, but you want to use it as a command, right? For that purpose, we need to give the executable permission. What is the command to give executable permission? chmod. Okay. So these are the three steps here. Again, see. Understand? First of all, I am downloading the Minikube. Why I am downloading Minikube? It's not a default command in Linux. So first of all, I want download. After downloading, what I am doing here? I am moving it to user local bin. Why I am moving to the user local bin? All commands need to be stored only. And after that, I am giving what's are here. Why I am giving executable permission? That's a file. If the file want to work as a command, we need to provide executable. And I am checking the minikube version. Is it clear now? First three steps. Update the server, install the Docker, install the minikube. Now I want to install kubectl. What I want to install? You can call as kubectl or you can call as kubectl. The concept is very, very easy. Just try to understand. Kubectl is a command line tool for Kubernetes. In Docker, which command do you use? Docker run, Docker pull, Docker push. In Ansible, you use Ansible playbook, Ansible hyphen galaxy, Ansible hyphen vault. In Git, which command you use it? Git. In Maven, you use MVN. But Kubernetes don't have Kubernetes command. Kubernetes don't have Kubernetes command. Kubernetes will have the kubectl command line tool. That means every command in Kubernetes need to be run from kubectl or you can call as kubectl. Is the concept clear now? So I'm downloading the kubectl here and again I'm moving it to user local bin and again I'm giving the permission for them to execute. Okay, this is step number 4, sir. After that, I am starting the minikube. Why? Because if you don't stop minikube, cluster will not be running. Okay, this is a script actually. In real time, you don't run these commands manually. You will put them on script and you will install them directly. Okay. Again, how many steps I said here? 4. Step number 1, update server. Step number 2, install Docker. Step number 3, why I need to use minikube? Why we are going to use minikube? Why? Because it's a cluster. First of all, I'll download. Next, I'll move to user local bin. I'll give the executable. Kubectl also not a default Linux command. Download, move to user local bin and give the executable permission. So now your Kubernetes is running. Your cluster is running, sir. If you want to see the command minikube status, is your minikube running now? What is minikube here? It's a cluster, right? Is your cluster running now? Running or not? And it is your master node. Master node means control plane. Master node means kubelet. It's a component or not, sir? API server, component or not, sir? It is kubeconfig. It is also a Kubernetes component to store the configuration files. Fine. So now next year, we are going to deal with the pods. Actually, I said, what is the meaning of a pod? Can you tell me what is the meaning of a pod? Pod is a group of. Why we are using the pod? Container in? Exactly. So in Kubernetes, we need to deal with pods. Why? Because already I said Kubernetes don't know about containers. Kubernetes don't know about. Kubernetes knows only about pods. It's the smallest unit of deployment in Kubernetes, which is nothing but a group of containers. Pods are ephemeral. Pods are what? That means short-living objects. If you create, they will come. If you delete, they will go. There will be no replicas. There will be no backups. Okay. Next. Mostly, we can use single container inside the pod. Already I said, pod is nothing but a group of containers. But in real world, basically in a single pod, I'll try to create only one container. Mostly, most of the times. It's a pod. I'll try to max place only one container. Okay. But in some occasions, whenever you want, you can place the multiple containers inside the pod also. The concept clear now? So if you go ahead and see, here what I have written, sir, mostly we can use single container inside a pod. But if there is any requirement, we can create multiple containers inside the same pod. Okay. But we don't do that generally. If there is any requirement, you can do. When we create a pod, containers inside the pod can share the same volume, same namespace, and same network. For example, if you go and see, I am creating one more pod here. Sorry, I'm creating one more container inside the same pod. Now these two pods can use the same network. These two pods can use the and can use the same volume. Clear now? That's it. So while creating a pod, you must specify the image. We need to give the pod image. Along with that, we need to give the necessary configuration and resource limits also. Kubernetes cannot communicate with containers. They will communicate only with pods. So we need to create the pods only. Is the concept clear now? Write this note point, all of you. Kubernetes communicate with only pods, not with containers. And pods will manage the containers. Kubernetes cannot communicate with, they will communicate only with pods. Okay, now fine. If I want to create pod, you can create the pod within two ways. How many ways, sir? First one is going to be imperative way. Which one? Second one is going to be the, let's understand what is the imperative way and declarative way. Imperative way means you can create the pod with command, not only pod, any resource in Kubernetes. If you want to create a Kubernetes resource, you can run the command. No, sir, if I want to create a resource with the file, that is called as declarative. If you talk about Docker, in Docker we use compose file, right? Why we use compose file? To create multiple containers. Why you are using compose file means to reuse. But if you run Docker command multiple times, it is not reusable, right? Here also, we can use the imperative method and declarative method. Imperative method means by using the command. Declarative method means by using the manifest file. Which one? So make the heading as manifest file and write the file which consists of, I am telling that only na. Manifest file means it consists the resource configuration. Manifest file consists of resource configuration. Manifest file means what? Consists of the resource configuration. Fine. So now if I want to create any pod, there will be two ways. Kubectl run command is the first method, that is for imperative. Imperative means by running the kubectl run pod name pod1 hyphen image. You can use your custom image. Already I have the image Raham Sheikh movies pay. Tag is the pod created. How to list the pod means kubectl. We need to use kubectl command for all. Kubectl get PO. It is going to show the list of pods. Is in the list of pods. What is the name of the pod? It's ready status, and I have only one pod. This is running. So this just created just 12 seconds ago. If I want to get IP address and worker node, just to give hyphen of void. It is going to provide some additional information of that pod. What is the command to list the pod? Kubectl get PO. You can write kubectl get POD, or you can write kubectl get PODS, or you can give kubectl get PO. Are these three showing same output or not, sir? Like that. No, sir, if I want to get the complete information. So kubectl describe pod. Name of the pod? Pod 1. This command will show the complete information of pod. Are you seeing complete information? Like that. Finally, if I want to delete that pod, command is kubectl delete command. Which command? So now it is going to delete the pod. Check it out. Is it gone, sir? So again, let's do the same activity. What is the command to create the pod? Kubectl. First of all, let's recap these commands. Command to create the pod. Kubectl run, name of the pod and image. What is the command to get the pods? I mean to list. Kubectl get pods. And if I want to get some additional information, hyphen o void. If I want to get complete information, describe. If I want to delete that one, kubectl delete pod and name of the pod. Whatever the pod you want to delete, give the pod name. Okay. So now let's do it one more time. Now you tell me the command. I'll ask you the question. Tell me the command to create the pod. Name of the pod. Image you can give whatever image you want. So okay. Already I have this image now, so I can use this image. Or you can use your custom image also. To list the pod. Tell loudly. Kubectl get PO. Shortcut is PO for pod. If I want to get the IP address and worker node information, hyphen o. If I want complete information, get in the pod one. If I want delete it, is the pod gone now? So in this way, you can be able to work with the pod actually. So it is which way, guys? Imperative or declarative? Imperative. Imperative means what here? Command. Now let's see the declarative way. So in Kubernetes, there will be a mandatory field. Mandatory field means like what exactly happened? For every resource, you need to specify 4 different fields: API version, kind, metadata, and spec. These are the 4 fields which is mandatory for every configuration file. How many fields are mandatory, sir? 4. What are those? Here I give given mandatory fields: API server, kind, metadata, spec. Without these 4 fields, we cannot create a manifest file. What is the meaning of manifest file? File which consists of resource. Create a file. I am doing abc.yml. API version. What is API version? Kind. What kind of object I am creating? Pod. In pod, P is capital, and in API version, V is capital. Meta data. That means you can give the name of the pod here. Name of the pod, I am giving it as pod 1. And what is the one more thing? Specification, right? And guys, see, indentation is very, very important. Okay. Without indentation, it won't create. Inside specification, now I'm going to create containers. What I'm going to create? Right? CONTAINERS. So here I'm giving the container name hyphen name of the container. First container name is container 1 and image for this container. Already we have the image, right? Latest. Just observe the observe that manifest file and see how many capital letters I have used there and where it is. How many capital letters are used here? In API version, V will be capital, and in kind P will be. Lot of you guys are going to do mistake here only, so don't do that mistake. API version V1 kind. I'm creating pod metadata. Here I'm giving the name of the pod is pod1. In spec, I'm writing about containers. What is the name of the container? What is the image? Is it clear now? That's it. Now, how to run this one means, see, kubectl create. I am creating a resource from the file. What is the name of the file? abc.yml. With the help of kubectl command, I am creating the resource from the file -f. What is the name of the file? abc.pod created. Tell me the command to list pods. Get PO. If I want to get the IP and worker node, if I want to get complete information, or if I want to delete, is it gone now? Commands will be same, but there I am writing manifest file. What I am writing? What is manifest file? Resource which consists of file which consists of resource information. So now write one main point, mandatory fields in manifest. Write this for mandatory fields. What are the mandatory fields in manifest? API version, kind, metadata, spec. Spec stand for specification. Is it fine now? Fine here next. Sir, here in pods will be having one drawback, sir. What is the drawback means? Once you delete the pod, you cannot able to restore. Already we seen, right? You delete the pod with your own hands, right? Are you getting any pod now? What is telling that? No restore. That means there is nothing in the current namespace. Okay. So like this, you can be able to work with the pod. Inside the pod, you'll have the application, sir. No, just assume inside the pod, you'll be having the application. If the pod got deleted, how can the application will be accessed? All right. It is a drawback or not, sir? For that purpose, in real time, we will create replica set. What we will create? Replica set is nothing but if you delete a pod, automatically it will recreate one more pod. Just like in Docker's form. If you delete a container, automatically it is recreating or not, sir? That is what we can call as self-healing. What we can call as self-healing. What is the meaning of self-healing? If you delete a resource, it is going to automatically recreate. That is what we can call as self-healing. So in replica set, we'll be having the self-healing now. Now, how to write the code for replica set? Already I have the code. I'll explain. But here, if you see, how many lines you wrote the code now? How many lines is this? Again, additional 8 lines you are going to write for the replica set. Okay. But that is going to be very, very easy. In replica set, so here I am going to change this configuration. Sir, for pod, what is the API version? But for replicas, it is app/v1. And in the kind, I need to put here replica set. In replica set, R and S will be capital. And metadata, name of the replica set is going to be, let's take movies replica set. Which one? Let's take. For example, okay. Here I am going to give labels. What I'm going to give? What is the label here I am giving? App is equal to, for label app is equal to, I am taking Paytm. What I am taking? So basically, in metadata, I am adding only 2 lines. What is the line I am adding? Labels. App is equal to, first of all, what is the meaning of label, sir? Here, replica set means multiple ports. Let's say your pods, for example. Who are pods, no? Your pods. Like, what's your name? Kirti, your name. And your name? Or Lakshman, your name? Parnita. So basically, if I say good evening Kirti, good evening Valakshmi, and good evening Parnita, I need to say multiple times, right? But instead of saying like this, good evening students, all of you are responding or not? That means instead of calling with names, if I call with a label, common label, all of you are responding or not, sir? That is what Kubernetes will do. Whenever you create replica set, for example, I want 5 replicas. How many replicas? So these 5 replicas, if I create, what will happen? These 5 replicas will be like 5 pods. How many pods? But here I'll take 3. 5 is not required. I'm taking 3. Pod number 1, pod number 2, and pod number 3. So all pods will be having different names, sir. Pod name will be, for example, let's take movies A12. For example, let's take. Okay. And pod 2 name is going to be movies B34, for example. And pod 3 name is going to be movies C45. Sorry, or like C56. For example, let's take. Here pods are having same name or different name? Different name. Like you. Your 3 names are different or not, sir? So if I want to call each and every pod, I need to spend a lot of time. But if I call all pods as Paytm, I'm gonna give one common label. I'm gonna be what here? Common label. This label name can be anything, but this label here I'm giving it as application as Paytm. What is the label here I'm giving? App Paytm. Now the moment if I apply this label to all the pods, what will happen? Every pod is going to respond for me. Simply label is nothing but assigning a unique name for different pods. Why I'm assigning means to manage multiple pods together. Why, sir? To manage multiple pods. Here I have given what is the meaning of label. Use it to make all pads as a single unit by assigning the key value. Okay. Without assigning the labels, you cannot manage them as a single unit, sir. If you can't manage them as single unit, can you manage all of them together? We need to spend a lot of time on that or not, sir? Like that. So next year. After giving the label, now I am writing the specification. This specification is about replicas. Okay. Spec. Spec about replicas. Spec about what? Sir, how many replicas I want? I want 3 replicas. How many replicas? And here I'll write selector. Selector means the main purpose of selector is to find the pods which is having same labels. What is the purpose of selector? Use it to select the pods with the same label. For selector, I am telling that to match the labels. To match the labels, app as Paytm. Okay. For selector, I am telling like this, selector, go and find the pods which is matching the label. Which is matching the label, app is equal to Paytm. Is the point clear now? Now again see. Label main purpose is to giving common name for all the pods. Why? Because individual pod will have individual name. We cannot manage them. For that purpose, we are assigning the label. Spec. Spec means here replicas. How many replicas you want? And here I use selector. Why I'm using selector? To match the pods which is having common label. And what is the label I am matching here for? That means I am matching the app is equal to Paytm for all the pods. Now this selector will find the pods which is having app is equal to Paytm. And this will be given to the replicas. Next year, I'm going to write template. What I'm going to write? What is the main purpose of template? If you go and see this one, I'll ask one more question. Sir, the main purpose of template is, where it is, sorry. The main purpose of template, TEMP, For example, how many pods you are having? How many pods you are having? These 3 pods need to have same configuration or different configuration? Same configuration. This template will provide the same configuration for all the pods. Template will provide same configuration for All the pods. If the pods is not having same configuration, how can they work as single unit, sir? Correct or not? Currently, you are taking DevOps course, you are taking DevOps, and you are also taking DevOps. Same configuration or not? You are attending to the classes, and you are also coming to the class, and you are also coming to the class. Same work or not? Like this, each and every pod need to be given the same configuration. Otherwise, it will not work properly. So for using the same configuration, I am using here template. What I am using? And inside template, I am writing metadata. Inside template, what I am writing? Inside metadata, I am writing this one. Labels app is equal to, inside also we have metadata, right? That means apply this configuration for each and everything. So I am writing this one. Don't worry, this you practice 1 or 2 times, it is going to be easy. Okay, no one will get it on the very first time. If you practice for a couple of times, it's gonna be easy. First of all, pod configuration clear, right? And after that, you wrote only 2 different configurations. Specs of replicas. Inside replicas, what you write? Purpose of selector to match the labels. Which label it need to match? Paytm. Next, I'm writing template. What is the purpose of template? To give the same configuration of pods. Here, I am taking the template from my metadata. In my metadata, label app is equal to, here also I have given label app is equal to Paytm. That's it. And this specification is nothing but container specification. Okay. So for all the pods, container name will be container 1. And for all the pods, image name will be Raham Sheikh. That is the manifest file for replica set. Now what I'm going to do is copy this one and go for AML. Why? Because that is not properly aligned, sir. Whenever your manifest file or like YML file is not properly aligned, you are going to use AML lint. This AML lint main purpose is to check the configuration and it is going to validate. Like configuration means like syntax mistakes. Of course, it is going to have a lot of syntax mistakes now. Let's correct. Click on go. You will be getting syntax mistake on spec. Exactly. Are you getting? So how to resolve means just inside the metadata, you need to write the spec. Inside the spec, now you want to write containers. Inside the container, now you need to give name of the container and you need to give image of it. Click on go, it will work fine. Is it working fine or not, sir? No? Copy and save. Guys, don't worry about the writing manifest file. If you practice for 3 to 4 times, it will come by default. Okay. So now how to run this manifest file, sir? What is the command I want to use? kubectl create -f. What is the name of the file? .yml. If I want to list replica set, kubectl get rs is the shortcut. Are you seeing replica set? If I want to see additional information, -o white. Am I getting, sir? If I want to see the complete information, kubectl describe rs. What is the name of the replica set? Am I getting complete information or not, sir? Now see the pods. kubectl get PO. Are you seeing the pods? This pod name is same or different name, sir? Different names. That is the reason why we are using labels. Okay, why? Because different names. If you want to see the labels, -show -labels. This command will show the labels. Now all the pods is having same label or not, sir? Now I can manage them together as a replica set. I can manage them together as replica set. Now what is the main advantage of replica set? If you delete this one, kubectl delete pod name of the pod. Automatically the moment if you delete, it is going to recreate. Just see. Deleting now. Now within next second, it is going to recreate one more time. Is it came again? 35 seconds ago. How many seconds ago? Again, if you want delete, give the command kubectl delete pod name of the pod. It is going to delete, sir, one more time. It is going to delete one more time, but again it is going to Recreate. How it is going to recreate? Because we are having replica set. Is the advantage of replica set clear now? Just like in Docker some we have seen, right? That's it. And one more thing is, if you want to scale the replica set, you can scale the replica set. The command is kubectl scale command. Which command? I'll show you. See, again, how many pods you will be having, sir? 3 pods, right? Currently, you are having 3 pods. If you want to get more pods, kubectl scale replica set. What is the name of the replica set? Paytm, right? What is the name of the replica set here? Movies, right? Oh, sorry, movies. Name of the replica set is movies. So give here and hyphen hyphen replicas. Currently, how many you are having? 3. Make it 10. Scale it now. And if you don't want to see labels, remove the show labels. If you don't want. Are you seeing 10 came? 10 coming or not, sir? Even if I want to delete remaining, I can use 5 now. Now automatically it is going to scale down for 5. Now which containers are going to delete first? Which pods? Last in? Already we seen on Docker Swarm, right? So same concept. Which container got created lastly? I mean, which pod got created lastly? It is going to delete firstly. How many you are seeing now? 10. These are on terminating or not, sir? So wait for a few seconds. You will see only 5 now. It's terminating. Wait for a few seconds. Is it gone now? That's it. Okay. So this is the way how you are going to deal with replica set. And if you want to delete replica set, give the command kubectl delete rs. What is the name of the replica set? Now replica set will be gone. Along with replica set, pods will also going to be deleted. See, do you have any pods now? Which status it is on? Terminating means it is going. So this is the session for today. Okay, in today's session, we've seen how to install Minikube and we've seen how to create pod and we've seen how to create replica set only. Now, which one is better, pod or replica set, sir? Which one is better, pod or replica set? How can you say replica set is better? Because one pod is deleted, you can create one other. That means you have self-healing, right? Self-healing you are having or not? But in pod, do you have self-healing concept? No, but in replica set, we have the self-healing concept. Don't worry about the manifest file. In real time, you will write the manifest file from copy paste only. If you practice, then only it will come for you. And I'm using my manifest file for you. Give me a second. And after practicing this one, delete this server, guys. Okay. Why? Because Minikube is paid, right? We are using T2 medium. Is T2 medium free? No. So it is paid. So delete this one. So you know what is labels and selectors? So comments also here I'm giving. Sir, in replica set, we have the drawback actually that we are going to discuss on tomorrow's session. Okay. I'll just tell you, drawback is we cannot update the application. It can create the same pods, but it cannot update the application. For that purpose, we use deployment, which I'm going to show on tomorrow's session. Okay. So that's it for today's session, sir. So now before going for doubts and queries, is the concept clear for you? What is Kubernetes and how we are going to deal with the pods? Okay. One tip I'll tell you, in Kubernetes, don't worry about the files. Files you are going to copy paste from application. Code, right? You need to focus on the concept. Even in real time, if we work, we will take the code from official documentation only. We don't write the code. Okay. The main thing about Kubernetes is concept. So I'm giving this history for you in the chart, in the notes here. You can take it and you can do practice. So that's it. Now, if you are having any doubts or any queries, we have some time to discuss. You can go and you can ask your queries. I'll tell it tomorrow session. It's almost like we covered a lot today, right? I'll tell definitely tomorrow. Okay. If there is any issue with the manifest file, how to read the manifest file errors, I'll tell on tomorrow session. Docker. Which troubleshooting you want? Ask like which troubleshooting you want. I'll teach you. Mm. That is due to CMD. Use exec command. I shown you exec command, right? From the exec you can run. Why? Because container you are running on detached mode now. Okay. Whenever you try to go, it will by default exit. Don't do enter into container. Use exec command instead of attached command. It will work. I already said this in the networking concept. I think you forgot. Might be. Fine. Sir, you have not included Docker GUI setup in notes. That I have given on the link actually. If you go here, are you seeing this link? Where is the link? So in this link, you have that one. Who asked for this question? So like Mahesh, you can get the GUI setup from there itself, Mahesh. Directly I have given on the repository. Okay, you can take it from there. So Sunil, that current PDF is for different purpose. Sunil. So here I'm giving the notes for Kubernetes. Why? Because Kubernetes PDF, like it's not on a complete pattern. Okay, so try to use notes for Kubernetes only for this concept. Yeah, I already said the update and upgrade difference. In starting of the session, I explained the Kubernetes update and upgrade, right? What you listen there? Just I'm asking like what you got to know from there. Update will show you the list of packages to update, but it won't update. But upgrade will do it. That is a major difference. అప్డేట్ రన్ చేసామనుకో ఏ ప్యాకేజెస్ అప్డేట్ చేయాలో ఆ లిస్ట్ మాత్రమే చూపిస్తుంది బట్ అప్గ్రేడ్ విల్ డూ ద అప్డేట్ ప్రాసెస్ దట్ ఈస్ ద డిఫరెన్స్ ఫైన్ సాటర్డే హాలిడే నో సాటర్డే వీ హ్యావ్ క్లాస్ సండే అండ్ మండే విల్ బి ద హాలిడే స్టిల్ ఎనీ క్వైరీస్ ఫ్రమ్ యువర్ ఎండ్ ఓకే దెన్ ఇఫ్ యూ డోంట్ హ్యావ్ ఎనీ డౌట్స్ యూ కెన్ లీవ్ నౌ థ్యాంక్స్ ఫర్ జాయినింగ్ లెట్స్ మీట్ ఆన్ టుమారో సెషన్ హ్యావ్ ఎ గ్రేట్ డే గైస్ థ్యాంక్ యూ